And the last speaker is Mr. Phillip Schönfelder, who will be presenting information extraction from text documents for the semantic enrichment of building information models of bridges. Let's welcome.
Okay, perfect. Thank you all for coming to this last talk of the session. My name is Phillip. I'm from the University of Bochum in Germany, and I'll be presenting the topic of information extraction from text documents for the semantic enrichment of the BIM models, actually. So let me start off with a few words of background. So the larger research scope of our research group is the automatic generation of BIM models for already existing buildings. And as we've heard in the previous talks, this is typically done with information from point clouds, for example, or also from 2D drawings. The thing is, however, that these mostly contain geometric information and not so much semantic information. Right, so you could theoretically infer the semantic information from whatever data you've captured. For example, let's say the point cloud includes also color information, then it would be feasible to also infer the material of the structure from that. But we've chosen a different approach that actually uses text documents that explicitly state the semantic information that we need in order to enrich the model with that information. We face a few challenges with this, and the main important one is that the documents that contain this information, they're not really standardized. They follow a certain structure, but still they differ a lot in style, which makes rule-based approaches, for example, approaches based on regular expressions, quite vulnerable to errors. And therefore, our idea was to develop a data-driven approach that is more flexible with regard to differences in style and format in these documents, and can then extract the semantic information from them. So on the left side, you can see an example of such documents. Now, I know that this may seem a little bit tabularly structured. However, this is a PDF file which does not have this tabular information embedded in it. This is actually just lines of text. Just some of the words are bold-faced and some are not. Basically, on the left side, you can see all the parameter names that we want to extract. And on the right-hand side, you can see the respective values. Now, the goal is to extract a tabular structure like on the left-hand side, on the right-hand side, which is the CSV file. So there you have all the information that you need in a structured manner. So left is the input and right would be the required output. Now, therefore, we developed a machine learning model. Therefore, of course, you need some corpus of training data. So we gathered 38 bridge records with that structure that I just showed you, and we labeled them in a sort of key value approach. Some also refer to this as a template fitting approach. So basically, each of the parameter values, this one here, is labeled with the class name of the parameter name. Right? So here it says, this is actually one line of text in this text document, which says element substructure. So that just tells us that the element we're talking about right now is the substructure of a bridge. And therefore, this is the parameter value of the parameter building element. So this is why we label this with the class label building element. We also implemented the so-called BI scheme that puts prefixes in front of the class names in order to distinguish the beginning of word or token spans, and also inside words like here, where you have multiple token spans. So this is the architecture or the schematic depiction of the architecture that performed best on the given data set. So basically, on the bottom here, you can see a line of text inserted to the model. This is actually German right now, but it basically reads a building element, substructure, building material, steel grade S235, and then the provider, the supplier company. So this is the input of the pipeline. And then the first step in the pipeline is to transfer all these words to an integer ID that is unique to them. And then in the next step, these IDs are embedded in a word embedding space, which is quite common in natural language processing. And then this is actually where the deep learning model starts. So we have a bidirectional LSTM layer here. On top of that, we have a conditional random field, which then gives the final outputs of the model, which are the word classes. We've tested multiple architectures, but as I said, this was the best performing one. We've also tested simpler models, just the CRF layer, for example, or just the LSTM layer. But we've also tested more complex models, like the by LSTM plus another CRF, plus another LSTM and CRF on top. But we found that this was the best performing one, with 97% both in precision and recall. And we've also optimized the hidden dimension. So that means the kind of the memory of the LSTM cells, and also the embedding dimension of the words in the word vector space. So these are, as we consider, kind of almost production ready values, but we still have some shortcomings, but I'll come to those in a minute. So this would be how to apply this model. So let's say that you have the input PDF document and you apply this machine learning model, and you get this tabular CSV structure. And then we also developed a Revit tool implemented in Dynamo, where you can import this CSV file, and which then lets you simply select the elements that you want to assign certain parameters and values to in the GUI of Revit. And then you can select which parameters and values from the PDF document you want to assign to them. Actually, this is the only step in the whole process that still requires human interaction. Otherwise, it's completely automated. So let me conclude. Basically, we've made this proof of concept for this end-to-end semantic enrichment method for the buildings, end-to-end meaning from the text document containing the data to the enriched BIM model. Now it is end-to-end, but as I said, there's still this one step that requires human interaction. Otherwise, it's fully automated. We find this proof of concept to be successful. However, the corpus that we used for this is actually quite neat. There's not a lot of noise in the data. The documents are quite similar to each other. And this is why future research aims to include also more diverse documents into the corpus, such that we can test whether or not the model also extrapolates to that kind of data. And also this last step in the pipeline where the human has to select the elements in the building model and the parameters that should be assigned to them should also be automated in the future. Yeah, so that concludes my talk, and I'm very open to your questions right now.
Excellent work. The part of it that requires the manual interaction, where the human looks at the text that was extracted from the PDFs and links it to the model. What supplementary documentation or information would a human need in order to make those connections? Because you have kind of removed all of the contextual information that is found in the PDFs that I think would kind of be required in order to figure out what component that, you know, small snippet of text is actually referring to. And so because you've removed all that contextual information, I imagine the human would actually have to go back to the original PDF to figure out what the extracted text is referring to. I don't know whether you've gone that far into the user studies, and is that a kind of challenge that you agree exists, and how do you imagine overcoming it?
Yeah, I understand the question. The thing is that, I mean, this is still the part that we try to automate, as I said, but if you take a look at this example, actually, it says here that element is substructure, and this would actually be kind of a headline in the PDF document, and everything that follows is the parameters associated with that building element, right? So this line would appear multiple times in the document, and then there would be a block of lines referring to that. So
what you're saying is that the text that's extracted, it's not ambiguous what component it's referring to.
Exactly,
it's very clear.
Yeah. The context is also extracted. Yeah.
Yeah, excellent. Thank you.
Thanks for the question.
Oh, thank you. Sorry that my computer has some problem. So as we are late, let's take one last question if anyone would like to ask. If no, we may end this session. So if no more questions, let's end this session. And